Welcome to Basic Foundation Maths Lecture 1. Today's topic is number system. So let's get into it. Numbers can be classified into multiple types. So if you look at the table, the first column represents the various types. Second column represents the symbols which are used to represent these types, and these are their examples. Example of irrational numbers is root 2, root 3, etc. Pi is also an irrational number. Many students think pi to be a rational number. So this happens because they think that pi equals 22 by 7, where 22 by 7 is a rational number and pi is an irrational number. So how is this possible? So let me tell you that pi is not equal to 22 by 7. This is an approximate value. Okay? So let's move to the next. There are three different types of decimal representation. The first are terminating decimals. So example 0.173. So we can write this as 173 divided by 1000. So as we can see, this is a rational number. So in general, terminating decimals are rational numbers. Second is non-terminating and recurring decimals. Example 0.555 dot dot dot. We can also write this as 0.5 bar, or we can also write this as 0.5 dot. Later in upcoming chapters we will see that we can also write this as 5 by 9, which by the way is a rational number. So in general, non-terminating and recurring decimals are rational numbers. Let's take one more example. 0.614614 dot 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 equals 614 whole bar, or we can also write it as 614 and then dots on the top, and then we can write it as 614 divided by 999. We'll see in upcoming chapters how we can write these. So this is also a rational number. So non-terminating and recurring decimals are rational numbers. Recurring means these numbers reoccur over and over again. Now the third type is non-terminating and non-recurring decimals. Example, root 2 equals 1.41423 and dot dot dot. So there is no pattern in this, and this is non-terminating. It keeps and it is non-terminating, meaning it keeps going on. Another example is root 3, which is equals to 1.732050,807 dot dot dot. This is also an irrational number because there's no pattern in this, and hence you cannot write this as in P by Q form. This is also an irrational number. Both root 2 and root 3 are irrational numbers because you cannot write them as P by Q form. So non-terminating and non-recurring decimals are irrational numbers. So let's keep moving. Next is surds. Surds are irrational numbers of the form this is read as nth root of a, where n is called the order of surd and a is called the radicand. Example, third root of 5. So this is the first form of surd. Surds can also be of the form b plus nth root of a. Here note that A and B must be rational numbers. Next is laws of surds. Also, also, nth root of a can be written as a to the power 1 by n. So this means we can write this as 5 to the power 1 by 3. So let's move to the next. Now we have laws of surds. So the first law of surd is nth root of a to the power n equals a. Example, cube root of 8, we can write this as cube root 2 to the power 3. So if we apply the above law, we'll get this as 2. Many students have the practice of doing it this way, that cube root of 8 equals cube root of 2 into 2 into 2. So since there are 3 times 2's, you get 2. Another example is square root of 25. So as you can see, there is no order mentioned, but we should know that this means second root of 25, which is equals to second root of 5 square, so you get 5. Now second law of third is nth root of a multiplied by nth root of b, you get nth root of a multiplied by b. Example, square root 2 multiplied by square root 8 equals square root 2 multiplied by 8. So you get square root 16. So this is equals to 4. Another example, cube root of 3 multiplied by cube root of 9. So this equals cube root of 3 multiplied by 9. So this equals cube root of 27 equals 3. Now one should memorize this formula from left to right as well as right to left, meaning we can split numbers like, for example, root 8, we can write this as root 4 multiplied by 2. So this equals root 4 multiplied by root 2. So this equals 2 root 2. Let's take one more example. So root 75, this equals, we can write this as, we know square root of 25. So we can split this as 25 multiplied by 3. So we will get root 25 multiplied by root 3. So this equals 5 root 3. So let's take one more example. Cube root of 16. So we can write this as cube root of 8 multiplied by 2. So we'll think of 8 because we know cube root of 8. So this equals cube root of 8 multiplied by cube root of 2. So this equals 2 cube root of 2. and so on. So the same approach we can apply in divisions also. So if I have root 2 divided by root 6, I can always take the root common and then write this as 2 by 6. So this equals root 1 by 3. So this is root 1 by root 3. So this equals 1 by root 3. As we can see, this law is very important to write numbers in a simplified form. So a student must learn and practice this method. So let's take one last example. Cube root of 250 plus 7 times cube root of 54. So we can write 250 as 125 multiplied by 2. This is because we know the cube root of 125. And then plus 7 cube root of, we can write this as 27 into 2. So if you realize, this will become cube root 125 multiplied by cube root of 2 plus 7 times cube root of 27 cube root of 2. So this will give you 5 cube root 2 plus, and this is 7, this is 3. So if you realize, we can directly write this as 21 cube root 2. Now if you want, you can think of this as we are taking cube root 2 common. So you will get 5 plus 12 cube root 2. So finally, this is equals to 17 cube root 2. So this is the final answer. So the next property is nth root of mth root of a equals n mth root of a. So this is the third property. So what does this tell you? That the orders get multiplied. So let's take an example. So if someone tells you second root of cube root of a, so this will be equals to 2 multiplied by 3 root of a. So this is sixth root of a. So another example, root of 3 is equals to, so do you realize the order here are 2, 2 and 2, because square root means second order. So this is 2 multiplied by 2 multiplied by 2 root 3. So this will give you 8th root of 3 and so on. So let's move to the next property. Okay, this is an important property. So in this property, we learn to change the order of the surd. So let's say I have nth root of a, and if I want to change the order here, so this order is n. So what I can do is, if I want to change the order such that this becomes p times, so I will make this p times n. So if I do that, I need to additionally take the power here of a. So nth root of a equals to n pth root of a to the power p. So this is used to change the order of surd. So let's understand these by an example. So I have square root of 3, which is, by the way, the second root of 3. Let's say I want to make this as sixth root of 3. So what I need to do is, so first let me rewrite this. Now what I want here is 6. So what I will do is, I will multiply this by 3 and take a cube here. The moment I do this, I'll get sixth root of 27. So if you use a calculator to calculate the value of this and this, you will see that both will give you the same value. So let's take a few more examples. Root 2 and then cube root of 3. So root 2 means second root of 2. So let's understand. So earlier, if this would have been square root of 2 and then square root of 3, we could have written this as square root of 2 multiplied by 3, which is square root 6. But here the problem is that the orders are not same. So if the order is not same, we cannot multiply. So what I need to do is change the order and bring them into a common order number. So I'll take LCM of the index 2 and 3. So if I do that, the answer is 6. So I need to convert them into 6. So let me write this and then cube root 3. So to make them 6, I need to multiply this by 3 and take cube, and then I do multiply this by 2 and take a square. So this will become 6th root of 8 and then 6th root of 9. So final answer will be equals to 6th root of 8 multiplied by 9. So this is equals to 6th root of 72. So if you see, to combine these two surds whose indexes are not same, we use this property. So a lot of questions will be asked based on this property. So let's take one more example, but not in multiplication. Let's say we want to divide. So if we want to divide root 24 by cube root of, let's say, 200. So if this would have been root and root, I would have been able to take the root common. So what I need to do is change the order. So to proceed, I need to change the order of these surds. So this I need to bring it to 6, and this also I need to bring it to 6. So I'll take cube and then square here. So now since the order are same, which is 6, so I can take this as a whole 6th root of 24 cube and then divided by 200 square. So if I simplify this, I will get this as 6th root of 216 divided by 625. So let's take one more example. Cube root of a to the power 4 b to the power 7, this equals to, so this is cube root of, we can write this as a cube multiplied by a multiplied by b to the power 6 multiplied by b. So this will give 1a outside, this will give b square outside, and the remaining is cube root ab. So let's take a last example. Square root of 8 a to the power 5 b and cube root of 4 a square b square. So if you see, this is second root and this is third root, so we cannot directly combine, so we'll have to change the order. But even before we proceed, we can see that we can write 8 as 4 into 2, so 4 is going to come out as 2. Similarly, a to the power 5, we can write this as a to the power 4 multiplied by a, so we can take a square outside. So finally we will get 2a square and then square root of 2ab, and then here we cannot do any further simplification, so we'll just leave it like this. Now next thing we will do is we'll change the order. So we'll multiply this by 3 and then take a cube. We'll multiply this by 2 and then take a square here. And then if you see, the order is 6 and 6, so we can now combine them and write them as 2a square and then 6th root of 2 cube a cube b cube multiplied by 4 square a to the power 4 b to the power 4. So this is 6th root, so we would like to see power 6. So we can write this 4 as 2 square, so this will become 2 to the power 4. So this equals 2a square 6th root of, this is 2 to the power 4, so this combines with this and it will become 2 to the power 7. This combines and becomes a to the power 7, and then this will become b to the power 7. So we can write this as 2 to the power 6 into 2. So we'll be able to pull out 1 2 outside. So this will become 4. We'll be able to get 1a outside and 1b outside. So this will become a cube b and then 6th root of 2ab. As we can see, this can be a lengthy process and student must learn and practice it. So next is comparison of surds. For example, if we have root 2 and then root 6, so we can see root 6 is clearly greater than root 2 because the order of these two surds are the same and the value 6 is greater than 2. So this is greater than this. Another example, cube root of let's say 9 and then cube root of let's say 5. So as we can see, 9 is greater than 5. The orders are the same. So this is clearly greater than this. The problem arises when the order of the surds are not same. For example, square root 2 and fourth root of 3. So one may think that fourth root of 3 is greater than root of 2 because 3 looks greater than 2, but we cannot be sure. So let's see how to do it. So as we can see, the order is 2 here and the order is 4. So we need to change the order. So what we'll do is we will change the order of these surds. So this is square root 2, this is fourth root of 3. So we will multiply this by 4 and this will take power 4 and this by 2 and this is a square. So this will become 8th root of 16 and this will become 8th root of 9. So if you realize this is greater than this. So this is greater than this and then this is greater than this. So to compare two surds whose orders are not same, first you need to convert them into the same order and then compare. Let's see one more example. Root 1 by 2 and then cube root of 1 by 3. So as we can see, the order here is 2 and order here is 6. So we can quickly convert this into 6th order and then take a cube here and then convert this into 6th order and take a square here. So the moment we do this, this becomes 6th root of 1 by 8 and this becomes 6th root of 1 by 9. So as we know, 9 is greater than 8. So 1 by 9 is smaller than 1 by 8. So this becomes smaller in magnitude. So square root 1 by 2 is greater than cube root of 1 by 3. So next is rationalization of surds. It means converting surds into rational numbers. Example. So let's say we want to convert a root 2 into a rational number. So tell me, what should we multiply it with to get a rational number? So a logical answer is, if you multiply this by root 2 itself, we get 2. Now this is a rational number. So this is called rationalization and this multiplier is called rationalizing factor. We can also see that root 2 is not the only rationalizing factor. If we want, we can also use 3 root 2 or 4 root 2 etc. to get a rational number. So this will become 3 multiplied by root 2 into root 2 will become 2. So you will get 6, which is a rational number. So this is also a rationalizing factor. This is also a rationalizing factor. So you can have more than one rationalizing factor for a given surd. So an important note is that rationalizing factor of a surd is not unique. You can have more than one rationalizing factor. So let's see more examples. So let's say we want to find the rationalizing factor of root 8. So one answer will be that rationalizing factor of root 8 is root 8 itself, because if you multiply root 8 by root 8 you get 8. So this is the rationalizing factor. So the answer is not wrong, but what we should try and do is first simplify the original surd So first step is write root 8 as root 4 into 2, so that we can write this as root 4 is 2 and then root 2. So rationalizing factor of root 8 is root 2. So let's check. If you multiply root 8 by root 2, you get root 8 into 2, which is root 16, so which is 4. So therefore we can see that root 2 also is a rationalizing factor of root 8. So I'll repeat the process. So I'll repeat the steps. So first we simplify the given surd. So here we got 2 root 2. So if we want to rationalize this, we only need to rationalize root 2 and not the whole number. So only thing we need to multiply this by is root 2. So root 2 is the rationalizing factor of root 8. So let's do few more problems. Let's say we need to find the rationalizing factor of root 75. So first step is we simplify this. So this becomes 5 root 3. So rationalizing factor of root 75 is root 3. So this is the answer. Now let's move to the next type. So let's say someone asks us, find the rationalizing factor of cube root 2. So what number should we multiply with this to get a rational number? So many students wrongly guess the answer to be cube root 2. So let's check this. So you'll get cube root of 2 into 2. So this is cube root of 4. So you realize this is still a surd. So this is not the rationalizing factor. So let's try again. So cube root of 2. So what should we multiply this with? So you will realize cube root of 2 square will give you cube root of 2 multiplied by 2 square. So this is cube root of 2 cube. So you'll finally get 2. So this means rationalizing factor of cube root 2 is cube root 2 square or cube root 4. So similarly, if I need to find the rationalizing factor of cube root a, it will be cube root of a square, and vice versa. If you want to find the rationalizing factor of this, the answer will be this. Example, rationalizing factor of cube root 4, which is equals to cube root 2 square, is cube root 2, because we can see cube root of 2 square, when you multiply this by cube root of 2, you get cube root of 2 square into 2, which is 2. So this is the rationalizing factor. If you use the above formula, you will get rationalizing factor of cube root 4 is cube root 4 square. Now this is also correct, but this is the most simplified rationalizing factor. So moving on, we should remember rationalizing factor of root a is root a. Rationalizing factor of cube root a is cube root a square. Rationalizing factor of root a plus root b is root a minus root b, because when you multiply these two, you get root a the whole square, which is a, minus root b the whole square, which is b. So you get a minus b, which is a rational number. Similarly, rationalizing factor of a plus root b is a minus root b. So student must remember these rationalizing factors. So let's do a few examples. So rationalizing factor of cube root 16. So first we simplify cube root 16. So you'll get cube root 8 multiplied by 2. So this is 2 cube root 2. So therefore rationalizing factor is cube root 2 square, which is cube root 4. Rationalizing factor of fourth root of 2 is, so do you realize fourth root of 2, so you need 2 to the power 4 so that the root completely goes away, so you need 3 more 2's. So when you multiply these two, you get 2. So rationalizing factor of fourth root of 2 is fourth root of 2 cube. The rationalizing factor of fourth root of 243. So first we simplify fourth root of 243. So this is fourth root of 81 into 3. So you get 3 fourth root of 3. So rationalizing factor of fourth root of 243 is fourth root of 3 cube, which is fourth root of 27. Now rationalizing factor of 2 plus 3 root 5 is 2 minus 3 root 5. Rationalizing factor of 2 root 3 plus 3 root 5 is 2 root 3 minus 3 root 5. So if you realize, generally we change the sign here from plus to minus, and you can also see that when you multiply these two, you get a rational number. Rationalizing factor of cube root a plus cube root b, this is cube root of a square minus cube root of a cube root of b plus cube root of b square. Example, rationalizing factor of cube root 3 plus cube root 2 is cube root of 3 square minus cube root 3 into cube root 2 plus cube root of 4. So why this works? So let's see. Because when you multiply cube root 3 plus cube root 2 with its rationalizing factor, so this becomes the formula for a cube plus b cube. So this is a plus b, a square minus ab plus b square. So you finally get a cube plus b cube. So this becomes 3 plus 2 equals 5. So this is the rationalizing factor for this one because it rationalizes these two sets. Next is conjugate. Conjugate of a plus root b is a minus root b and vice versa. So conjugate of a plus root b is a minus root b and conjugate of a minus root b is a plus root b. Similarly, conjugate of root a plus root b is root a minus root b and vice versa. Example, conjugate of 5 minus 2 root 6 is 5 plus 2 root 6. Conjugates generally help in rationalization. Now there is one special type of conjugate. So let's see it with an example. 2 minus root 3 and 2 plus root 3. So let's multiply these two. So when we multiply these two, you get 2 square minus root 3 square. Now this is 4 minus 3 equals 1. So essentially 2 minus root 3, you can also write this as 1 by 2 plus root 3, where 2 plus root 3 is conjugate of 2 minus root 3. So these types are also called conjugate reciprocals. because these conjugates are reciprocals of each other. So let's see one more example. 7 minus 4 root 3, 7 plus 4 root 3, so you get 49 minus 48 equals 1. So therefore 7 plus 4 root 3 equals 1 by 7 minus 4 root 3. So these are also example of conjugate reciprocals. Now let's see some questions. If 3 plus 2 root 2 divided by 3 minus root 2 equals a plus b root 2, find a comma b. So here we need to simplify this to get something of this form where a and b are rationals. So to get from LHS to RHS, we need to get rid of this denominator. So how do we get rid of this? So let's see. The solution is we write the LHS, and then to get rid of the denominator we rationalize it. So we multiply this with its rationalizing factor or its conjugate, which is 3 plus root 2, and then we balance it so that we are not changing the number. So we will multiply 3 with this whole thing. So 3 will get multiplied with 3 plus root 2. So this got multiplied with this whole thing, and then plus 2 root 2, this will get multiplied with this whole, and then in the denominator you have 3 minus root 2 multiplied by 3 plus root 2. Now this is a minus b and a plus b, so you get a square minus b square. So the denominator becomes 3 square, which is 9, minus root 2 square, which is 2. In the numerator you get 9 plus 3 root 2 plus 6 root 2 plus 2 root 2 multiplied by root 2. So you get 2 into 2, which is 4. So this becomes equals to 9 plus 4 is 13 plus 6 root 2 plus 3 root 2 is 9 root 2 divided by 9 minus 2 is 7. So we can write this 13 plus 9 root 2 divided by 7 as 13 by 7 plus 9 by 7 into root 2, so that we can get this in the form of a plus b root 2. So here a becomes this and b becomes this. So finally a equals to 13 by 7 and b equals to 9 by 7. Next question is, if root 3 equals to 1.732, find 1 by root 3 minus 1. So if you directly try and substitute the value of root 3 here, it will be difficult to divide 1 divided by decimal numbers. So instead we can first rationalize the denominator. So 1 by root 3 minus 1, we can rationalize the denominator by multiplying this by its conjugate, which is root 3 plus 1, and then balancing it. So this will give you root 3 plus 1 in the numerator, and the denominator, this is root 3 minus 1, root 3 plus 1. So this will become a square minus b square, that formula. So this is root 3 plus 1 divided by 3 minus 1. So this will become 1.732. We substituted the value of root 3 here and then plus 1 divided by 2. So this is 2.732 divided by 2. So this is easy to divide. We get 1.366. So let's do one last question. If root 5 equals 2.236 and root 2 equals 1.414, then evaluate. So to proceed with this, one may think that we need to rationalize this denominator and rationalize this too, But we don't need to separately rationalize. If we take the LCM directly, you will see it is automatically getting rationalized. When you take LCM in the denominator, you get this, and then this will become 3 times multiplied by this. The way you take LCM and simplify this, and this will become 4 times root 5 plus root 2. So this will become 3 root 5 minus 3 root 2 plus 4 root 5 plus 4 root 2. This whole divided by, this will become root 5 square minus root 2 square. So this will add to give 7 root 5, and this will give you minus root 2. So this equals 7 root 5 plus root 2 divided by 5 minus 2. So this equals 7 multiplied by 2.236 plus 1.414 whole divided by 5 minus 2 is 3. So you finally get 15.652 plus 1.414 divided by 3. So this equals 17.066 divided by 3. So we get 5.689. So with this, our first lecture ends. Thank you.